Trigonometry, Chapter 5, Trigonometric Identities, Section 2, Verifying Trigonometric Identities, Video 7, Verifying an Identity, Example 6. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. All right, let's take a look at our sixth identity example. We're going to verify the identity 1 over 1 minus sine of theta plus 1 over 1 plus sine of theta equals 2 sine squared of theta. Take a wild guess which side we're going to start on. We're going to start on the left side because it's messier. And in fact, I think I'm going to do something that I did in the previous video. By default, I'm just going to take this and put it over in a PDF so that I can write it out the way I want it to see. So I'll pause the recording just for a second so that I can make that happen. All right, so here's the identity we're proving. Notice I did write it with x's instead of thetas. The variable actually doesn't matter as long as you're consistent across the board. So we're going to start with the left side, the 1 over 1 minus sine of x. I can draw better than that. I had a stylus, but it stopped working, so I'm having to use my finger. Plus 1 over 1 plus sine of x. And make a decision on whether we're going to do something algebraically or trigonometrically. Well, since this already has signs and there's no squared signs, we're probably going to do something algebraic. We're adding two fractions. We're going to get a common denominator. In fact, I'm going to erase this, and I'm just going to start setting up the common denominator here. So what do we need to get a common denominator? Well, the first fraction has 1 minus sine x in the denominator. The second fraction has 1 plus sine x in the denominator. So let's multiply the first fraction by 1 plus sine x over itself. And then for the second fraction, the 1 over 1 plus sine of x, we're going to do the same thing. We're going to multiply it by the denominator of the second fraction. So 1 minus sine x over 1 minus sine x. Now, unfortunately, this line took up the entire row. So we're starting with the left side by doing an algebra move. We're setting up a scheme to get a common denominator. So let's see what happens. Our common denominator ends up being 1 minus sine x, 1 plus sine x. And hopefully you're thinking, those are conjugates. You're right. But my move wasn't driven by using conjugates. My move was driven by getting a common denominator. On the top, we have 1 times, that was supposed to be a highlight, not sure what happened to it. On the top, we got 1 times this parentheses plus 1 times that parentheses. Well, luckily, 1 times anything is easy, and I just realized that this closed parentheses over here was not drawn correctly. Little things like that drive me crazy. All right, so let's put the numerators together. The first numerator is 1 times 1 plus sine x, which is 1 plus sine of x. And then plus, that plus in the middle. The second numerator is 1 times 1 minus sine x, which is 1 minus sine x. And now we can clean this mess up. On the top, the ones cancel, and we have, excuse me, the ones do not cancel. The signs cancel. Let's try that again. The minus sine x and the plus sine x cancel, and that leaves just a 2. And on the bottom, if we do a FOIL, we'll get 1 minus sine squared of x. Oh, this is working out nicely. I haven't done a look at trigonometry yet. That's about to change because 1 minus sine squared x is cosine squared x. That's a Pythagorean identity, and the reciprocal of cosine is secant. So the reciprocal of cosine squared is secant squared. That was a reciprocal identity, which is exactly where we wanted to go. So needless to say, this identity was driven completely by algebra. The algebra of getting a common denominator, cleaning up the mess you made, and then at the very end, 2 quick identities, Pythagorean and reciprocal. So when you see a trig identity, like this one, that you're asked to verify, don't panic. As long as you have some algebra moves in your arsenal, attack it and see what happens. This one collapsed very, very nicely.